When I was asked by Teachers TV to teach a maths masterclass, I decided to tackle a topic that can be brought alive by a hands-on approach to suit a range of pupil learning styles. It's a topic that is possible to have a lot of fun with. I'm hoping that's what this group of Year 6 students from a number of North London schools will think too. OK, right, we'll hold it there. We're getting there. Daniel, come with me. Come with me. Bring your board. Bring your board. Now then, he's got 0.1, 4, 2, 8, 5, 7, 1, 4, 2. And you stop there. Let's chant it out. 0.142857. 142857. OK, so we've got a 6-digit recurring decimal. Fantastic. Wow. OK, now to demonstrate this a bit more clearly, I want you all up in any order. Grab a pen, grab a whiteboard. Excellent, excellent. All the way down the line, looking good, looking good. Get a nice, neat line. OK, so you've got an even more important thing. Can you stand that side of Tajana? OK, we've got a decimal. OK, 0. OK, 1, write a 1 on. 1, we're going to write this decimal down. 4, 2, 8, 5, 7. So write your digit down and hold it up so I can see it. And on, and on. Anyway, this is a very long one. How long is this going to be then? Forever. Forever. Brilliant. It's a recurring decimal. Does it terminate? Does it stop? No. No. Right then. On the side of the board facing you, I'd like you to write down another number. You ready? Yeah. Your shoe size. Write it down. Write your shoe size down. Are you a size 1, a 2, a 3? Lovely. So we've got 0.41. Let's shout them out. 0.41.
1.
Shout.
3. 5. 5. 6.
Shout.
4.
Shout.
5. 3. 4. 3. 3. 4. 5. 5. 5. 5. 7. 5.
So, what's the next one going to be?
9.
What's the next number going to be? 9, because I told you my shoe size, didn't I? What's the one after me going to be? Don't know. Why don't you know? Why don't you know?
It could be anyone.
Could be anyone. Is there any pattern to these numbers? No. I thought there was, because we had a few 5s in a row. Then you went and spoilt it all. You had a 7. Is it ever going to have a pattern? No. Why?
Everybody can grow and everybody's shoe sizes change.
OK, just because he's a 6, does it mean, does it affect what you're going to be? Yeah. No, you're in a completely random order. We have decimals that do behave like this, that carry on forever and ever, but the digits have no particular order, no pattern, they don't recur. In fact, some of these numbers are so special, they're all around us. In fact, they're absolutely beautiful. Wow. Yo, I'm MC Round. Welcome to my hood. This is my shop. Don't it look good? I don't do corners and I don't dig straight. What I do is circles. I think they're really great. Yay, this is my shop, look at it. I don't do squares and I don't do those silly polygons, all those straight edges. I hate them, I hate them. What I want you to do is to come up to my shop in a moment and pick something that's round. Well, that won't be difficult because everything's round, everything's circular. I'll just check me. Oh, hang on a minute, I think I've left it on too long. But, oh, come on up, quick, it's hot. It's ready for you. Now then, form a line, form a line. Grab something. OK, there's a cake. Oh, grab it. Take your round thing and go. Lovely pork pie. We've got to do 2 important things. Do you like my bling?
Yeah, I want
good.
Bling.
Nearly a circle, isn't it? If I break my circle right down the middle, I get 2 semicircles. What do we call that length there? Is that what you're going to say? Diameter, OK. Clever Clogsies. What about the distance all the way round? Now, we could say perimeter, but there's a special name. Jasper. Circumference. So, 2 measurements. Let's get measuring. And I want you to write those 2 numbers down. All the way round. OK, you put it round. Yep, that's it. Write it down. 37 or 37 point, whatever you think. So we're measuring right across. Have we measured our diameter? That's it. OK, that's your diameter. Lovely. OK, you put it round. Yep, that's it. OK, we OK? Diameter goes right across a circle. The circumference goes right around the edge. You've got 2 numbers. Brilliant. What I want you to do now is pick up your pen and your calculator. I want you to do the circumference number on your calculator, put it into the calculator, divided by the diameter number. And I want you to remember or write down the number that you get on your calculator. So circumference all the way round divided by diameter all the way across. OK? Right, you've got a number. You've got a number. Right, come on up with your item. You're the first in the line. Bagel, what's your number? 3.16. Not bad. Take your bagel. Right. Ooh, that looks a nice cake. What was it?
3.076.
Lovely. Would you put that back in the oven, please? OK. Excellent. Toilet roll.
3.16 recurring.
3.16 recurring. Put that in the bin then. OK. What's this?
3.5 recurring.
I meant what flavour? Oh, sorry.
3.5 recurring.
3.5 recurring in the bin. So go and sit down. 3.5. Brilliant. We've got lots of values here. A lot of them start with 3 point. This young man here was whittering on, wasn't he, about having some pie. And I told him it was a quiche, but he still's going on about his pie. So shall we let him have a say about his pie? What were you talking about with your pie?
Because you don't need to measure the circumference, you just need to do the diameter, because you just times the diameter by pi, which is 3.14.
You think pi is 3.14. So you're giving this division a special name. You're saying that if you get any circle, yeah?
Yeah.
And you measure its diameter all the way across, and you multiply it by
3.14, but the actual calculation of pi is a 40-digit number.
It's a magical number. And it does actually go on forever. I need 4 volunteers. OK. Jasper, Daniel, Megan and Astrid. OK, Megan over here. Put your finger on the top, your finger underneath. Lovely. Astrid, you can be the roller. Guys, stand behind them. Pull it out slowly. 3.141592653 8 9 7 9 3 2 3 8 6 4 2 6 3. Wow, it goes on and on and on for ever. Is it recurring? Is there a pattern? Can you spot a pattern? There's 2 3s. Is that a pattern? No. There's no pattern at all. It goes on and on forever and ever and ever. It's called pi. People have thought about this number for ages and ages. In fact, people with computers in this day and age have actually calculated this value to 80 million billion digits. You can go onto the internet and actually look at the value as it currently stands. OK, so pi has no pattern at all, and no one's ever been able to discover a pattern. OK, if you'd like to put your pies down, the pi number, OK, and sit yourselves back down. OK, so pi is a decimal that goes on forever. It looks beautiful, and it's all around us. We can actually use pi. Now, if we make it 3.14, it's a good approximation, isn't it? 3.14? Pretty good. OK, so when might we use pi? Well, I need a couple of volunteers, actually. Elena and Rian, up you come. It's a pretty big tyre. Uncle Tom, my great-uncle Tom, used to be a farmer, but he's retired now, and he's left me this wheel. It's pretty big. It's pretty big, but it's circular. Here's a question. Whoa. I'd like to place my eggs as close as possible to that tyre, so that when it does one complete turn, it doesn't crush them. how close can I put my eggs to that tyre so that it can get as close as possible without getting crushed? Do you think I could put it here and get away with it? Yeah. Hold it, hold it, hold it. We're just guessing, aren't we? What's the point of guessing when we can work things out? Right then, another couple of volunteers. Benji, Megan, up you come. Benji and Megan, we've got some metre sticks here. First of all, I want you, 1 metre stick between you, to measure from this side the diameter. Let's measure it across. Okay, we're going right across. It starts here, so it's actually over 100 centimetres, isn't it? What have we got? Have you got it yet?
140
Pretty good. 114. Write that down. 114 what? Metres?
centimeters.
Centimetres. Okay, brilliant. Or 1.14 metres. I like decimals. Let's stick with 1.14. What do we have to multiply it by to get an idea of the circumference? Alex? 3.14. 3.14. Let's do that on the calculators, yeah? Anyone got an answer? What have you got?
3.5796.
3.579. What about that bit? Say 58? Do we all agree? 3 metres 58?
Yeah.
3 metres 58, okay. Let's have a look. How far can we get them? So if we put a bit of tape there, do you reckon, Ruby? So as soon as it hits that, it's going to get crushed. So guys, with your measuring sticks, I want you to measure from this point. We'll lay the first stick down, like so. Okay, that's 1 metre. 2 metres. And we need another stick. Do you want to use that one? Okay, so to there. Do we put it there then? Like that, are you happy with that? Do you want to adjust it a bit? Yeah. Okay, move your sticks out of the way, let's roll it. Okay, everybody sit down apart from the 3 rollers. So, do you want the eggs to break? Do you really want the eggs to break? If you want the eggs to break, shout, break! Break! I think most of us want to shout break. Are you ready after 3? 1, 2, 3, let's roll. Break! You're waiting for that tape to come back round. It won't break. So we've managed to use the maths to do a calculation and we've achieved a result. But the thing is, put your hand if you really wanted to break them. Round here. Shall we? Shall we? Shall we? Ready? 1, 2, 3, break them! Yay! Brilliant. Fantastic. Oh! Now then. Oh! Hey, this is no joke. Oh, look at that. Scrambled eggs, right. Okay, but a cracking time. We've looked at numbers, decimals that go on forever and ever and ever. And they were really fun. And we've looked at pi in particular. That's a special number. It's all around us. So there you go. We've looked at all sorts of decimals. We've looked at terminating decimals, recurring decimals, these funny decimals that don't have a pattern. It's fantastic. One thing's for sure, decimals are great. You know what I say? I love decimals. Decimals forever!